Okay, so I'm Yamilka Cuellar, and this is a small, I would call it learning report, or I don't know, that I did to save all like the main information about Java collections. Um, and I did like this diagram because it's very easy to see how it's a structure. And the main thing about Java collection is that it's a framework that has some interfaces and classes that work together to retrieve and store information, and it makes it easy to access to the data. And like you see, it works like a hierarchy, and we have the root that is called collection, and from there you have different interfaces, set, list, queue. All of them have different classes that work in different ways. Um, and you can see for set the different um, classes that work with that, and the different implementations you can use. So uh, I did want to this, yeah, to this map a lot to focus in which one of them are and everything. But um, to be more specific, Java Collection is an architecture in Java that groups elements into a single unit. It is used to store, retrieve, manipulate, and communicate aggregate data. The collection framework contains interfaces, implementations, and algorithms. And I have a small um, specification of what interfaces are. They represent collections and declare the actions to be completed, generically using different types of interfaces. Interfaces only contains abstract methods. It can extend multiple interfaces and cannot be instantiated. Um, Implementations refers to the fact that interfaces need to be implemented by classes. They are reusable data structure, and algorithms, methods that perform computations like searching, sorting, and objects that implement collection interfaces. They are also reusable. These are some of the benefits of Java collections. Reduces programming efforts, increase program speed and quality, allows interoperability among unrelated APIs, reduces effort to learn and to use new APIs, reduces the effort to designing APIs, and fosters software reuse. Um, these are different interfaces types. Uh, Collection, set. Inside set, you have hash set, and I put the declaration for each one of them. Um, and one thing about hash, even in hash set or hash map, is that everything that contains hash would be presented like in an unordered way because of the hash structure. So instead of an array list, that it would be presented like in an ordered way. So all of these implementations have some differences that would make more sense sometimes to use in some way, and other depending of your needs. Um, the link hash set has characteristics from both hash set and tree set. It uses a hash table with a link. This implementation of the set interface, it provides insertion order iteration, but still keeps running as fast as hash set. The thing with the speed is that because hash set doesn't take the time to order things, it will work faster than the list of the implementations that provide order um, list. That it would take, yeah, it would take longer. So then we have,
I was gonna say, very good, thank you. It looks like you got a few more slides.
yeah, I'm not very good explaining. That's why I did it this way, because yeah, if you had some, yeah, you could get better idea. Because yeah,
I, I think you're doing very well.
so what other thing I stuck for me? Linked list vector. You.
Means feel free to just sum up like the main points for them. You don't have to read everything on every slide.
Yeah, no, that's what I'm trying to see. Yeah, the mainly thing is that some things are ordered, like some of the implementations order the data in some way, some not. Like I said, the ones that contain hash map or hash set would be in order, and it would work faster. For the map, I think map was different than the other ones, but because it takes two values instead of one, it cannot contain duplicates, keys. Um, and what else? Some of them also like include null values and some not. Um, so which made it tricky when I was trying to test the that the instructor said that we should, once we are doing the sandboxing thing, that we should test the try and catch to get exceptions throws. And yeah, for some of them that didn't that accept null values, like it was tricky to find a way to get those exceptions. Uh, what else? Yeah, and I put like some resources there, but yeah, this is all, yeah, the main things, like the main concepts, but the rest I did was working with the code, and that was what helps a little more understanding. And and it's where you can actually see, like, start testing, like which things would display the list in an order way or not, like which ones would accept no values or not. Yeah, once you're practicing the code, you would see the different behavior of each implementation. Um, so um, yeah, I think that's it. Yeah.
All right. Thank you very much. I'm going to go ahead and stop this.